Hi, this is Andrea Hendricks. Let me show you how you can use the graphing calculator with inverse functions. Specifically, we're going to talk about how to verify two functions are inverses by graphing, verify that two functions are inverses by using the table feature of the calculator, verify that two functions are inverses by composing y1 and y2, and then also the calculator has the ability to draw the inverse function, so we'll talk about that. To verify that two functions are inverses by graphing, I've actually already done some screenshots from the calculator. We look at y1 is equal to 2x minus 1 and y2 is 1/2 x plus 1/2. Whenever we graph those two, we see that those are symmetrical about the line y is equal to x. So that's one way that we can tell that those functions are inverses of one another. Now, we can also verify that they're inverses by using the table. This can be a little bit ugly because what we're trying to find is that if a point AB is on the graph of F, or in this case on y1, then the point BA would be on y2. Okay, so like for instance in y1 we have the points 0, -1, 1, 1, 2, 3, 3, 5, 5, 9, and 6, 11, just to name a few. So on y2, what we would expect to see would be -1, 0, 1, 1, 3, 2, 5, 3, 9, 5, and 11, 6. So let's verify just for these few points. So here is -1, 0 is on y2, 1, 1, right, it's on y2, 3, 2 is there, 5, 3 I did not, oh it's actually here on this original one, 5, 3, 9, 5, so if x is 9, y is 5, and 11, 6. So yep, just from an examination of those few points, it does look like these two functions are inverses. Okay. Now, we can also verify that two functions are inverses by composing y1 and y2. And so let me show you how to do that on the graphing calculator. So if you enter y1 and y2 and you want to do y1 of y2, which I have written here, which is, if you want to call that f and g, f composed with g, we can do that. To do that, what I would have to do is go to the vars key in yvars and choose function and y1. And then parentheses, put in y2. Okay, don't do no sign because that would mean multiplication. I've got to evaluate it at the function y2, so that's why I put this in parentheses. We don't have the composition symbol to use here. Then I'm going to select y2. Okay. Now what's supposed to happen? y1 composed of y2 should be x. So whenever I press graph, notice that I have the function y1 and y2, and this is my function y3, which is x, right? That's the line y is equal to x. And I could also do the composition in the other direction by do vars, yvars, function, y2 this time of y1. Okay, and then graph. And I still see that I get this graph, which is y equals x. So that tells me that the two functions composed together give me x, which is the proof that they are inverses. So I should just write a note here. Whenever you're verifying that, this should draw the line, or should graph. Putting draw and graph together, sorry, should graph y is equal to x. Okay, so I had to do the vars key to get to the y1 and y2. Now, the graphing calculator can actually draw the inverse function for me, so let me show you how that will work. Let me clear out everything but the original function and just show you the graph of that original function there. Now, to do the graph of the inverse, what I can do if you do the draw feature, so do second program, and if you arrow down, you're going to see something that says draw inverse. There it is, number 8. Press enter. And now what I want to do is draw the inverse of y1. So I'm going to go to my vars key and go to y vars and function and select y1 and press enter. And there it drew for me the graph of the inverse. And so what you could do at that point is now enter what you think is the inverse function, which was what, 1/2 x plus 1/2. I think that's right. And then graph. And see, and it shades over that inverse that we drew in, so we know that we did it correctly. That's pretty nifty, huh? Okay, so that's all the skills you need. Let me see if there's anything else I have on here. Nope, that's it. So if you have any questions on using the calculator with inverse functions, let me know. And I'll put some notes in here so that you'll have that for the draw inverse. Okay, thanks. Bye-bye.